All right, today we're going to look at section 2.3. We're going to do this in 2 days. So what we're going to be doing is analyzing graphs. So day one here, all we're going to be doing is looking at graphs, and we will be able to find domain and range from a graph and determine the intervals on which a function is increasing, decreasing, or constant. The zeros, this part, the number 1 up here, the zeros and the even and odd functions we will do next time. 4 isn't even in this section. I needed to get rid of that for our objectives. So we're going to start, we're going to skip the zeros part. So skip in your notes to where the graphs, it's the bottom of the first page of your notes. There are 3 graphs down there talking about domain and range. So remember when we talk about domain and range, domain is our x values and range is our y values. So you're just listing all the values in interval notation that are your x's and your y's. So for domain, you read your graph from left to right, so you're reading it across this way, and you can see, well, it goes on forever in both directions, so our domain would just be negative infinity to infinity. Our range is our y values, so you start at the bottom of the graph and read up. Our smallest y value is right here at -3. And then the graph continues forever, so it goes to negative infinity. So our range is -3 to infinity. I have a bracket on my -3 because it can equal this. It's a solid little point right there on our line. Our next example over here, domain, again, we're doing our x's. So our x's go from this point to this point, which is -7 to 7. Those are solid points, so it's going to be in brackets. Our range, again, our lowest point is down here where the red point is, goes up to this top one. So our range is -3 to, this should be a 6, not a 1, -3 to 6. Brackets again, because you only use parentheses on infinities and if there's an open point. For example, here, our domain goes from -5 right here to +1. But at -5, it's an open point. So at -5, I would have a parenthesis, a bracket at 1. Our range, again, starts down here at -3, goes up to 1. I know I have an open and a closed point. The closed point overrides the open, so these would both be brackets at -3 to 1. So you'll have some problems on your assignment where you're just finding domain and range. Next, we have increasing, decreasing, and constant functions. So you're going to be looking at a graph. You're going to read your graph from left to right every single time, just like you're reading a paper. And then just think about it. If it's going up from left to right, this would be increasing. If it's going down from left to right, it's decreasing. And then constant would just be going straight across when we look at a graph. And again, we'll write it in interval notation, and we always record the x values when we do these. Okay, so we're looking here. If your graph looks like it's stopped, but it's not really, assume has arrows on it that keep on going. So we're just going to look at our graph. This is the function, but we don't really need to worry about it just by our graph. So start from left to right. If I start on the left-hand side right here, it's going up. So it's increasing till it gets to this point right here. So it's increasing from negative infinity to -1 because remember, we are always using our x values. And then at -1 right here, it starts to decrease. So at -1, we would have -1, 2, and then it decreases till it gets to this point, which is 1. So -1 to 1, decreasing. And then at 1, it starts to increase again. So we're going to put union, and then it's from 1, and it goes on again forever, so 1 to infinity. When you do this in WebAssign, this union, you have to use the union symbol that's in the sets in the toolbox. If you use a U, it will say it can't read your problem, so make sure you're using that. Okay, constant, this one's not constant anywhere, so you can do like does not exist. That's what they're going to have you put in WebAssign. If you're writing words on paper, you could just write none, whichever works, it's fine. So let's look at another one. If we look at this graph, again, reading from left to right, so start of my upper left, my most left point right here is -3, and it is increasing until I get to that point, so increasing from -3 to 1. Then right here at 1, it goes straight across, so it's constant from 1 to 3, so constant 1 to 3. Increasing, decreasing, and constant, we will always use parentheses. And then it starts to decrease right here, so it's decreasing from 3 to 5. And then that is all we are looking at. So that is day one. Then for the end of day 1 right now, you have an assignment on WebAssign. You do not need to turn in any homework or any paper to me because it's just reading graphs and writing answers. And that is the end of day 1. So now I'm going to start day 2 notes. So day 2 notes, we're going to go back to the very beginning of your notes. So we're going back and we're going to go to where we're going to be talking about zeros right here. So go to your zeros, which is the beginning of what our notes are going to be, and we are going to find zeros of a function. So zeros of a function, if the graph of a function of x has an x-intercept at a0, that's how we write our intercepts as ordered pairs, then a is a 0. So zeros and intercepts are the same thing. A 0 is where the graph crosses the x-axis. To find the zeros, we'll set the function equal to 0 and solve for the independent variable. Okay, 0 is just finding zeros, set your function equal to 0, and solve, which means we're going to have to use some of our possible quadratic formulas, square roots, different things that we've learned. So here's some examples on finding the zeros. So step 1, find the zeros, set your function equal to 0. Okay, now we need to solve this. Well, so we've learned how to solve quadratics in Unit 1. We use quadratic formula, we use completing the square, just depending on factoring, whatever you want to do. So you could use quadratic formula, you could factor, whatever you feel like doing. I am going to factor this. So I factored by splitting the middle term. Remember, 4 times negative 5, what multiplies to give me negative 20 and adds to give me a positive 19? Well, that's 20 and negative 1. So I split my middle term. Remember then, we are going to put these in parentheses and factor out what they have in common. So I factored a 4x out of the first one, negative 1 the second. Our parentheses should be the same. Factor again. Actually, I just wrote the same thing again. Factor x, take out the x plus 5, and then I have 4x minus 1. Set both factors equal to 0. So in here, you would say x plus 5 equals 0. And that would give me x equals the negative 5 down here. And then I would set 4x minus 1 equal to 0. Solving for x would give me the 1/4. And these are our answers. You can just write them as 2x equals and have your 2 things on there. Okay, you don't really have to show me this equaling 0. You can, but you don't have to. How about part B? I have the square root of 3x squared minus 9x. Again, we'll set our function equal to 0. So you can have your square root on there. But if I square both sides right here, right, then the square and the square root go away, and I just have 3x squared minus 9x equals 0. So we didn't really have to do, so we just, when you have a square root, you can ignore the square root and just set what's underneath it equal to 0. Again, I'm going to need to factor here. I'm going to factor out my GCF, so I'm going to factor out a 3x, and I'm left with x minus 3. We would set each of those equal to 0, so 3x equals 0, x minus 3 equals 0. So that means this would be x equals 0 if I divide by 3 right here, and this would be x equals positive 3. So my 2 answers are 0 and 3. When we're finding zeros, whatever our largest exponent is, over here I had a 2, and again I found 2 zeros. Again, I have an exponent of 2, and I found 2 zeros. That will work every single time. Whatever our largest exponent is how many zeros we should find. So let's look at part C right here. Here, the square root of 3x minus 14 minus 8 equals 0. So the first thing I'm going to have to do is add this 8 over. So add 8 over. We need to get rid of the square root because we're solving for x. We did this in Unit 1, solving. So I equals 8. Then we need to square both sides. So I square both sides. This radical goes away. This would be 64. So 3x minus 14 equals 64. Add 14 to both sides. 3x equals 78. Divide by 3. And our x is 26. Notice this x only has just the exponent of 1. And I got 1 answer. All right, our next one. 7x squared minus 14 over 3x plus 1. When you're finding zeros of a fraction, we don't care about the bottom, because if I were to set this equal to 0, I'd multiply by what's on the bottom and it just goes away. So every single time you have a fraction, you only have to set the top equal to 0, don't worry about the bottom, and solve for x. So here I would add the 14 over. So 7x squared equals 14. Divide by 7, x squared equals 2. Then remember we square root this and put the plus or minus. I cannot simplify the square root of 2, so my answer would just be x equals, and you can write plus or minus radical 2. If it's on WebAssign, you would have to write it as radical 2 and negative radical 2. Remember, you can't do plus and minus in WebAssign. Okay, so then we had the graphs, so we're going to skip all of our graphs and our increasing, decreasing that we already did, and go to the very end of our notes on symmetry. So you will be asked to figure out if something is even or odd, and that means they have y-axis or x-axis symmetry. So here, a function is even if each value of the domain, this is true. If f of negative x equals f of x, it's even, which means it has y-axis symmetry. We need to know all that. Okay? A function is odd if this equation is true. F of negative x equals negative f of x, and that means it has origin symmetry. So if it's not even and it's not odd, then we would say it's neither. So it just depends on what we're looking at. So we're going to determine if these are even, odd, or neither. So start with A. I have the square root of x squared minus 9. Always start, I think it's always easiest, what we have to do is we have to show if this is true or if this equation is true. Okay, notice both of them have the f of negative x in them, so I always start with that one. So when I look here, the first thing I want to find is f of negative x. So that's just evaluating a function. Instead of x in here, I am going to put in the negative x. So I'm plugging in negative x for x, and now I need to simplify this. If I square a negative, a positive comes out, right? Think about it. Negative x times negative x makes a positive x squared. So when I simplify this, that means that square root of x squared minus 9. So this simplified, now this is my f of negative x. I check it. Does it match this? The answer is yes. So if those two things are equal to each other, that means that this is even and it has y-axis symmetry. Sometimes it might just ask even and odd. Sometimes it might ask if it has a certain type of symmetry. So if those two things are true, you write yes, you're done. You don't even have to check the other one. Okay, so let's do the same thing over here for part B. We're going to find f of negative x again. That's the first thing we want to find. So everywhere there's an x, I'm going to plug in a negative x. That's all. I replaced all of my x's with a negative x down here. And now I need to simplify it. I need to decide if when I raise it to a power, it is a even or a positive or negative value. So you can think about this being negative 1. So if it helps, in your calculator, type in negative 1 to the 7th with parentheses. And if you get a positive value, it's positive. If you get negative, it's negative. In this case, if you do negative 1 to the 7th, you're going to get a negative value right here. So that means I have a negative and a negative here, and a negative here, which is going to make it a positive. So this f of negative x, so this would be negative 2. This negative 1 x to the 7th stays negative x to the 7th. I need to erase that part. Whoops, we'll just do this. Colors. So the negative 2 stays, and this negative stays. If I multiply them together, I get a positive 2x to the 7th. Again, anytime I raise this to an odd, if I do negative 1 and I cube it, I'm going to get negative 1 out. So then a negative times a negative makes that a positive 8x cubed. And here, 3 times negative x makes this negative 3x. So this is my simplified f of negative x. Does it match the original? The answer is no. So now I need to find negative f of x. So when I find negative f of x, that means all I have to do, I'm taking negative, and then f of x goes in parentheses, negative 2x to the 7th minus 8x cubed plus 3x. So I have to distribute this negative into everything. So that would give me 2x to the 7th plus 8x cubed minus 3x. Now I compare this to what I simplified up here. Are those equal? The answer is yes. So when those are equal, then I know that my function is odd and I have origin symmetry. Okay, so that was an example of our origin. Excuse me. One more example. F of x equals 5x squared over x plus 4. So again, we want to find f of negative x. So I would have 5 times negative x squared over negative x plus 4. Well, if I simplify this, if I square that negative, it becomes positive, so that gives me 5x squared on top. I can't do anything with that negative x on the bottom. So that simplified doesn't match this. They are not equal. So this is not true here, so it's not even. So now I need to do negative f of x. Well, when it's a fraction, you don't make the top and bottom negative. You're just going to put a negative out front, and you have 5x squared over negative x plus 4. Whoops, sorry, that should be a positive x plus 4. Okay, does this match this up here? It doesn't, because this negative's out front. This negative only goes to the x, so this is no. So if none of these are true, then your answer is just simply neither, and there's no symmetry. Okay, so you'll be asked to find whether things are even, odd, or neither. And that was our last example, so that is all we are doing today. So your assignment will consist of things that are from day 1 and day 2. If you have any questions, please let me know.